All right, so let's now talk about week number 10, part 2. There's only one question I just checked right before the class. There's only one slight clarification I would like to make, two actually, very quickly, and then I'll take your question. The first one, so this has to do with when we talk about a composite design pattern. So remember, we actually presented to you 2 design attempts. And let's talk about the first one. There could be some slight confusion over here. So if you look at the example code I put over here on this page, so over here I said D is of type disk. So I just didn't really put the full name in my notes over here. So the disk over here really referred to the disk drive, which is over here, right? So disk really exists. So it's really referring to this class, right? It's a simple clarification. Okay, number 2, which is about some confirmation about cohesion. So your fellow students make the following statement. Let's read it together. If a child class inherits attributes, commands, or queries from the parent classes, but they don't really use them, for example, these attribute commands or queries inherited, would that violate the cohesion principle? I would say that's quite accurate about how you can, one way of thinking about whether cohesion is really satisfied or not. So for example, when they talk about a child class, so for example, let's say the disk drive. No, let me highlight it. Let's say this is a disk drive class over here. Apparently, according to the architecture, so you should also train yourself by reading the design diagram, not just the code. I think it sometimes could be more effective, especially when you have a bird's eye view of the whole thing. Apparently, the price is going to be inherited to the disk drive. Let's write it down implicitly, of course. And also the add child, also the children. So both of these as well, especially, right? So 1 and also 2. They will also be inherited to the disk drive class. Let me write it here. So children and also add child. Okay, so these 2 features, well, basically, this one's a command, and this is an attribute, for example. So all of them are inherited. However, we discussed for design attempt number 1 is actually flawed because for a disk drive, if you think about it, it really belongs to the category of base cases. In that case, these two features should never be used. Should never be used, even though they're compilable, which is very bad. You can see, for example, one of the example we did. If you try over here, okay, actually there's something let me write it down again. It's not reading the notes. So for example, if we say disk dot add child over here, and then let's say we try to add a card, this will actually compiles according to the design because the add child is indeed inherited to this particular class, but it certainly does not. Excuse me. It certainly does not make any reality sense. Okay, I'll just say it doesn't make sense, but you know what I meant. So that's why should never be used. Should never be used. So once we reach this conclusion over here, you can see quite clearly why it is violating cohesion, because if you actually inheriting some features into this particular class, but you concluded that they should never be used. So why would you declare them in the first place? So that means they don't really belong to this particular class, right? So that violates cohesion, right? It's quite an obvious conclusion here, right? So that violates cohesion. Violates cohesion. So what your fellow students said over here, it's very accurate. I just want to make it a little bit more explicit for everybody. So later on in the design documents, you might be asked to judge, to justify. So why your design actually satisfy the various design principles. You know, we talk about many. So as you see the project design document instruction before the deadline for phase 1, most likely by the end of Wednesday, you will see more information, okay? I just want to mention. So whenever you're asked to judge about a particular design decision, number 1, you should really know what the definition is. And number two, you may just want to quickly review how we talk about those design principles. I think at the top design principle we have talked about so many times, for example, single choice principle and also cohesion. And the new design principle that we started to talk about, we'll start talking about tomorrow for the visitor design pattern is called open-close principle. And also we talk about information hiding, right? So these are the various principles you want to keep in mind and try to reflect yourself when you write your design documents, all right? All right, any question about cohesion over here in general? Any question? All right, since everybody is okay. And that's about it. Okay, I don't have many questions from the Google Docs since yesterday, but I think yesterday we already spoke about quiz number 8 requested by one of your fellow students. You might be here, and then we spoke about the exercise I gave to you for the composite design pattern, and also we spoke about a little bit about multiple inheritance, but just to clarify, what I really meant by descendants, and we spoke about subcontracting. Right, we spent the most time yesterday clarifying, precondition and postcondition. All right, so that's about it. Now I'm ready to take your questions if you have any. Anybody? Yeah, if you got questions related to the projects, I would suggest to maybe refer that to my office hour. My office hour will start at 4 p.m. I think that'll be more suitable to ask. But let's maybe take some questions for your quiz. Okay, I will just pause over here, just give you some time to think about any questions you like about lectures. It can be even from the previous week, I don't mind. All right, so one question from Nina. Does the program always check the parent's contracts at the runtime? It does. Okay, I will clarify this. For example, if the static type is descendant of A, will it check the contracts of A first? Okay. So basically, let's talk about this. Okay. You know what? I think let me just reuse one of the example from mine. Actually, let me build from scratch. Okay, quickly. So let's talk about general case. You can definitely refer to the smartphone example, which I spoke about in the lecture. Okay, so let me just talk about here. So let's say we got 2 classes for inheritance. Okay. So class, we got parents. And then let's say we got some routine, right? Let's say there's no parameter, just make it simpler. And then we got require. Okay, and the precondition, let's just use alpha. So just be consistent with the symbols I use in the lecture. And also we got ensure. So it's going to be beta, all right? So this is the parent class. And then let me draw the child class, and then we can talk about at the runtime. Okay, just give me one moment. Okay, so we got inheritance relation over here. Okay, so let's say we got inheritance. Let's now draw the child class. Okay, also the same routine. I just omit the redefined class, right? Of course, if you want to do this for your developments, you have to say redefine explicitly. But let me just omit that. Let me say I'm going to redeclare the contracts. When I say redeclare, meaning that I'm going to add some additional one. Require else, and then gamma, and also ensure then. Okay, it's going to be delta. All right, and let me put this into a box. All right. Okay, so at least you are clear about the class relation. Okay, pretty much like how we set it up for the lecture. All right, so let's say this. Since I think it's also a good time to just summarize, in case you were not here yesterday. Let's talk about design time. In the design time, that means you're going to do something on a piece of paper, to actually do some proofs according to how you learn in 1090. So for preconditions, you have to prove that alpha implies gamma. Basically, you want to say alpha over here implies gamma over here, meaning that gamma is actually weaker, and also it requires less, right? So that's the requirements. So require less, and also that's weaker. And also it's easier to satisfy, right? We talked about all these yesterday. All right, another one. Let's say, let me use green over here. And let's talk about post condition. We got beta here, and also we got delta over here, right? So let's talk about post conditions. It's going to be delta implies beta. So the delta over here implies the parent's post condition, which means it ensures more. And it's actually stronger. Right? So I think for your quiz number 10, you want to get very comfortable about, for example, if I give you a predicate, if you know in your mind what you're supposed to prove, for example, A implies B. Let's say this is what you're supposed to prove. So there are different ways to say this, in English, right? For example, you might want to say, let's say, let me just put this into context. Let's say you got precondition, right? You can extrapolate this into post condition as well. Precondition, just for example, right? Just an aside, okay, to give you a little bit tip. Let's say you know that for predicate A and for predicate B, you know that what you're supposed to prove is the child precondition, the parent's precondition A implies the child precondition B, right? Let's say, in that case, there are different ways to say that in English. So you can say A, of course, you can say A is stronger than B, right? You can also say B is weaker than A, right? That's kind of symmetric. You can also say B requires less than A because it's weaker. And also you can say A requires more than B. So you got 1, 2, 3, and 4. So all these 4 are basically equivalent. They are really referring to the same logical implication. You can see somehow natural language cannot be as precise as the logical assertion like this, right? Just something to remind you. All right, let me go back to the original question about the runtime. All right, so this so far is really about what's going to happen in the design time. Sorry, let me just draw a little better. Okay, so let me box it over here. Okay, so that's about the design time. Let's talk about runtime. What's going to happen in the runtime? So for the runtime, let me try to give you 2 scenarios and see exactly what's going to be checked. Okay, so let's say this. Let's say if I have some objects, let me just use maybe blue over here. Let me just first of all say runtime. All right, when I talk about runtime, and then let's say we have objects of type parents. At the moment, we cannot call any routine on object yet because it's simply just void. And once you start creating the objects with some dynamic type, and as we learned from the inheritance lecture, so given that this is the static type, what are the possible dynamic types? It can be any of its descendants, which can be itself or the child, right? So now we got 2 scenarios to talk about. Yeah, okay, let me enumerate them. So let's talk about scenario number 1. So let's say I'm gonna start with by saying creates over here. Let's say, let me just be more explicit. What should be the dynamic type? I would say parents. Okay, I would say par over here. So you know that's parents. Obj.make, assuming that make is a constructor. All right, after this, I'm going to say obj.r. All right, and then let me just write another 2 lines. You might be able to guess what I'm going to write. So let's say creates. Okay, so now I'm going to change the dynamic type for the same objects. So let's say child. Okay, chi. And then it's going to be obj dot make. All right, and then I'm going to call the same line obj dot r. All right. Okay, so that's good. So far, so good. Basically, first of all, you can see the obj over here, the dynamic type is really the parents. And obj over here, the dynamic type is really the child. And they're really calling the same routine over here, R and R. So now, of course, according to dynamic binding, we know very well, in this case over here, it's going to call whatever the implementation it is over here, right? Let me just draw a little bit better. So when you call this R, think about implementation-wise, it's going to call whatever version that's defined over here. And when you call the R over here, it's going to call whatever definition that's implementation that's defined over here, right? That's quite obvious to you, right? That one you should be okay. So now we want to think about exactly the precondition and postcondition that will be checked. That's basically Nina's question. So I'm just going to talk about precondition first. So we know that for the precondition, it's going to be checked right before, right? Right before the call, right? So I'm going to put over here. Oh, let me just use a different color. Otherwise, they look very similar. Let me use orange. So let's say the orange one over here in the pre-states, and also the orange one over here in the pre-states, right? The exact precondition that will be called, will be checked, depends on the dynamic type. So now we know that in this occasion, the dynamic type is actually parents. In that case, you're just going to call basically definitely the precondition that's defined over here, and also to be disjoint with all the preconditions in the ancestor classes. But in this case, we simply say parent is the top, just to make it easy, to make it simpler. So now in this case, you're simply just going to check alpha. Okay, I'll put alpha over here. So what about the R over here? So now the dynamic type is actually the child. So not only that you're going to call gamma over here, but also you're going to accumulate the alpha that's inherited. And the way we accumulate precondition is by using disjunction. So it's going to be alpha, or, okay, it's a disjunction, gamma. It's a little bit small over here, but hopefully it's readable, right? You can see exactly what's going to be checked over here is a little bit different, right? In the case, the dynamic type is simply the parent type. So you only check the parents. In the case where the dynamic type is a child type, you're going to check not only the child precondition, but also disjoint with the parent's precondition, right? Hopefully that's clear. And then it will be very similar when we talk about the postcondition. Let's do it. For the postcondition, you can it's going to happen in the post states over here upon the termination. Okay, so now following the same logic, dynamic type over here is for R is parents. So that means we're going to just check to see beta. And then when we get to this particular call over here, so now the dynamic type of object is now the child. In that case, it's going to be basically delta, but not only just delta, but also whatever postcondition it has inherited and put them together using logical conjunction, right? So it's going to be beta, the parents, and delta. All right, so that's basically what's going to happen at the runtime. So Nina, does that answer your question? Okay, very good. Okay, just want to make sure. All right. All right, guys. I think again, it's a summary of basically what's really being said in the lecture. But I think having such a summary will be useful, especially later on once we get to the exam period when you want to review the lecture notes for the exam. I think having such summary will be useful, right? All right. Next question, if any. Hopefully the composite design pattern is not too difficult, right? I think I would say the most interesting design pattern for this semester, for me personally, I think it's the visitor design pattern. So that's why for the coming week, starting from tomorrow, there's only the visitor pattern to learn. So that will be the last design pattern. But I do have some optional learning resources for those of you who are keen to actually explore further. It's optional. So if you want to, you can explore that for the visitor design pattern. Otherwise, just study the lecture slides and lecture recording. I think it's a challenging design pattern to understand. All right. All right, anything else, guys? Okay, again, another question from Nina. For the composite design pattern, is it only useful if there is more than one class that needs to use it? More than one class that needs to use it. So what, Nina, what do you mean by more than one class that needs to use it? For example, you know what? To really help our discussion, I would suggest I put the composite design pattern over here and then we can discuss it. So I might need you to help me to elaborate your questions a little bit. So let me get prepared first. Okay, this is our composite design pattern, but I would suggest, actually, I put this guy here, all right? So that's the most general case over here. Ah, okay, for example, furniture. Okay, that's good. Okay, I kind of definitely read your mind. Okay, it's good. So I would say, how do you know if you should use the composite design pattern? That's a good question here. So basically, as I kind of started to say about the, to emphasize for design pattern, remember the very first design pattern that we talked about in the course is the iterator, right? It was back in maybe week number 3 or week number 4, around that. So I mentioned that design pattern is basically some recurring, the solution to some recurring problem that software developer think that's really the most elegant solution to really adopt. However, you definitely don't have to apply every possible design pattern into your particular projects. That'll be overkill. You have to know exactly the problem scenario to apply a particular design pattern. So I would say there is something that you want to do maybe by yourself when you review the exam, to really enumerate all the design patterns that we talk about in the course, and for each design pattern, make a table yourself, right? Let me get back to Nina's question in just a moment. However, I would suggest something you want to do by yourself that will definitely help your understanding, not just this course, but beyond this course as well. You want to consider making a table. Okay, first of all, you have the design pattern. Right. For example, we talk about iterator. We talk about singleton and etc. Right. We also talk. I think that these two patterns are before the reading week, and also after the reading week, we also talk about quite a few. And then the second column should be you talk about context. So the context is really about basically under what circumstances should you consider use this particular pattern, right? So apparently for singleton pattern, it's very easy. It's actually when you want to have sharing, right? I'll just make it very easy, but I can try to elaborate what I really meant by sharing. And you're definitely using the singleton design pattern in both your lab number 3 and also the project extensively, right? I don't need to emphasize that. Context will be very important because you want to know when to use which pattern, right? If the pattern is not really suitable to be used, you better not use it, because using the wrong pattern can easily lead to very difficult to understand code. You just get yourself confused. All right, context is one. And also the next one will be architecture. I think for this one here, you don't necessarily have to put down any words over here. But this one here, remember for every design pattern I gave to you, I also gave you the bound diagram for each one of them. So at this point, you may just want to, before you look at the diagram again, try to picture in your mind exactly what classes should be there, and also how are they related to each other, right? Remember, every time when we talk about architecture, it's really about client-supplier. There's one kind of a relation between classes where you got inheritance. Okay, so that's about architecture. And then you want to talk about implementation. think about if there's any particular implementation tricks or implementation detail that you should really know about when you review this pattern. For example, when we talk about singleton pattern, the most important use will be the once keyword. And also we talk about using the expanded classes, right? So these are the special things you want to review yourself. Okay, finally, which I think is also maybe the most important aspect, well, equally important as architecture, is the runtime. You want to know very well about how things work together for a particular pattern at a runtime. For example, let's say for the singleton pattern, remember basically for each pattern, I always end the pattern by visualizing exactly how things work by using a small test. So that's something you want to think about as well. Okay, so that's going to be a table that you want to draw by yourself when you review the exam, right? So this table can have as many entry as possible depending on how many design pattern that we talk about, right? I'll just want to suggest something to you, all right? Okay, let me go back to this particular example. So what would be the scenario for using the composite design pattern? So when to use? I would say the guiding principle would be if the system is recursive. And more precisely, whenever we talk about recursive system, you like a recursion, as you learned from 2030. So what's really recursion? Recursion is a way to solve for solving problem, and then your solution contains two parts. So one is about the base case. Base cases, there could be more than one. And also we talk about recursive cases. You can think about the recursive cases is really like a subtree, like internal nodes of your tree, right? And the base cases are really like a leaf or external nodes, recursive cases. Okay, I would say as long as you know the recursive your system can be structured or built recursively, so that would be a very good indication that you should really use the composite design pattern. Well, for example, over here, you can see the general concept we are talking about right now is the equipments. But however, equipments can be categorized into two parts. Either this drive, in which case you can think about these are simply the leaf nodes for any equipment's tree, right? So for example, you may have cabinets, right? Start from cabinets, you got another cabinets, and then maybe over here you got chassis. Under chassis, let's say you got this drive, and this one just got, I don't know, maybe just another chassis. And then we got maybe video card, right? Just for example, right? You can see for the base case over here, so they are simply just the leaf nodes of your tree. Whereas for the composite components, like a recursive cases, that's simply the internal nodes over here, right? So that's quite obvious. So whenever you find that the way your system work at runtime is actually recursive, that can be formulated as a tree. So that means you should really try considering using a composite design pattern. Okay. So Nina, I think to responding to your question, so to really use a composite design pattern, it's not about how many classes want to use it. It's more about the structure of your system. The reason that we talk about this particular single trace principle, right, is because you might have more than one recursive system that exists in your projects, in which case you don't really want to duplicate the code for the composite. That's why we want to factor out this particular class as a generic class outside. But that part over there is not to do with the composite design pattern. It's really about the recursive structure. Nina, make sense? Very good. All right. Well, guys, I think beyond this particular Q&A, I will highly suggest you may want to start thinking about building such table for your study for the exam, right? If you got any table like this, but you're unsure how to fill in a particular entry, yeah, speak to me. I'll be happy to help you complete that table. All right. All right. Anything else? Any other questions? Okay, I can pause a bit longer. Okay. Okay. Okay, guys. Any more questions? Just I will wait a little bit longer for you to think about. Any more questions? Everybody is okay? Okay, I think I'll wait for 1 more minute if you guys are okay. So we'll let you go earlier. And then if you got any question related to the projects, come to my office hour. All right, guys, really no more? All right. So I presume everybody is okay, right, for the lecture? All right. Yeah, if you're still behind studying the lecture, yeah, you definitely want to catch up, right? I understand that the project is very demanding, but yeah, try to really manage that. Any tip about quiz number 10? Let me see. I think for the subcontracting part, you want to be very clear about, sorry, over here. For the subcontracting part, you want to be very clear about this particular summary page I just spoke about, right? To really know all the facts, right? Of course, you don't, well, of course, if you kind of, for some reason, forget about it, but it's open book quiz, you can always refer to the slides. You want to be very clear between design time and also runtime, right? And also familiarize yourself about how to describe the logical relation over here in English, right? Because afterward, the question will be stated in English. So you want to be very clear about them. So that's about the subcontracting part. And for the composite design pattern, I think the tip would be very similar to your quiz number 9 tip. You want to be very clear about the pros and cons for the various design that we spoke about, right? So for design number attempt, I think for design attempt number 1, that one there, somehow you want to judge by cohesion and single choice principle. And also for design number 2, also you got to judge by cohesion and single choice principle. And then for the composite design pattern, the ultimate one, you want to understand why you will actually satisfy both cohesion and single choice principle, right? I think for the weekly quizzes, I'll tend to just ask you about more about facts about the design, about pros and cons. And of course, sometimes I might just give you some logical question, maybe about reading some contracts, and then to determine it's just multiple choice. But I think for the exam, so the question type might be slightly different, in which case I'll talk about maybe later after the last day of the class, right? All right, but I would say for quiz number 10, if you really follow through the the lecture and lecture notes, and if you got time to go over the Q&A, I think it should be okay, right? You got 20 minutes as usual, so hopefully that will be not so challenging, right? All right, any more questions about the lecture? So everybody is okay? Should I call it a day? All right. So I think since everybody is fine, okay. Yep, I still got office hour at 4 p.m. So I might just end the meeting now, and if you got any more questions, get in touch with me. You know how to reach me. All right, so I will see you in the Q&A maybe next Monday about another lecture, but get in touch with me if you got any questions. All right, take care.